Hello and welcome to this webinar hosted by Quantum Materials Corporation. And today we are focusing on fighting counterfeits with quantum dots and blockchain. My name is Peter Harris and I will be the MC and moderator for this webinar, in which we will hear from the leadership team at Quantum Materials. They'll be providing an overview of this exciting business, as well as some information on the quantum materials offering and a review of likely use cases and the market opportunity. You may submit questions at any time during the short presentations using the Q&A button at the bottom of your screen. We'll be answering those questions following the presentations, and in the event that we have more questions than we have time to address them, we'll respond one-on-one via email over the next day or so. We'll also use email to cover, where possible, questions not directly relevant to the focus of today's webinar. We'll be recording this webinar for an on-demand playback, so check out our website from tomorrow for information on that option. For potential business interest and follow-up following this webinar, you should direct your comments and questions to our Chief Revenue Officer, John Hardigan. His contact information will be displayed while we are answering your questions. Finally, we have an obligatory blue sky statement to display. But now it's time to begin by hearing from Stephen Squires, CEO of Quantum Materials Corporation.
Thank you, Pete. As most of you are aware, or have recently become aware, QMC has been on the forefront of nanomaterial discovery, and more specifically, quantum dots and uniform nanoparticles. Although there are many uses for these materials, most are based on applications where their unique optical properties can deliver a significant benefit. Our discussion today is on their use as optical identifiers or signatures. We're going to demonstrate how we can use light to restore our trust. But first, what are quantum dots and why are they significant? Quantum dots are atomic crystals. They can be as small as a single molecule. What makes them, there's about 1 trillion in a single droplet. So they're extremely small. When we combine more than one of them, we can make an artificial molecule. What makes them very significant is their ability to convert light or to up-convert photons to electrons or electrons to photons. For the application we're discussing today, what makes them very interesting is their ability to emit very precise color across a very broad range of the color spectrum. As Pete said in his intro, the webinar is to provide further insights into using quantum dots to thwart anti-counterfeiting, a $1.2 trillion per year global problem that not only results in damage to brand reputation and loss of revenue, but all too frequently results in loss of life. I think it's newsworthy today where we've seen frequently these kind of episodes happening with the vaping industry. It's also happening in the automotive industry. So, I mean, I think that it broadly affects almost everybody that's any type of a consumer in today's world. By using quantum dots as overt or covert optical signatures and tying these to the distributed ledger, we can for the first time tie the physical world to the digital, greatly diminishing and possibly someday eliminating counterfeits. Before I hand this over to our CTO, Jay Williams, to describe the QDX Ledger platform, I want to take a moment to explain why dots produced using our patented QDX flow process have raised the bar that all optical emitters are judged by. The QDX flow process is the only process that can consistently produce quantum dots with very discrete optical emissions. So what we're saying here is that they can hit very specific segments of the light spectrum and produce very pure color in very close increments. In essence, this enables QMC to produce quantum dots that can emit light in as small as 5 nanometer increments throughout the visible range and the less than visible range. And for those of you that aren't familiar with that, that's roughly the visible range is 400 to 700 nanometers. The less than visible is below 400 and above 700. So this provides a very large range of color emission for us to be able to use as unique identifiers. In fact, this results in an almost unfathomable number of distinct optical emitting combinations from which to create optical signatures that can be embedded into an object and tied to the blockchain, virtually tying the physical to the digital. Imagine a world where virtually everything could have an inseparable, unique identifier. You could run a query to view its entire history. I think you can see where widespread adoption of the QDX Ledger platform can restore our trust. I'm now pleased to turn it over to Jay Williams, our CTO, a renowned expert on all things supply chain and the blockchain, to learn about the QDX Ledger platform.
Howdy everyone, and welcome today. Today I'm going to try and give a quick overview of how we do some of the things that our CEO just spoke about. One of the most challenging things that we've been confronting for many years in the supply chain is how do we connect the physical and the digital? So for many years, in all supply chain applications, we've put things on products, whether those are UPC codes, RFID tags, or any kind of QR codes or anything else. So now having the ability to create artificial molecules, we can actually embed those in the actual products that we're going to be monitoring through the supply chain. So quantum dots being atomic crystals mean that we can actually tie those signatures into a serialized distributed ledger, which keeps everything immutable. So not only can we embed serialized identifiers into individual products, we can actually track those in a distributed ledger in an immutable way for audit purposes, identification purposes, authentication, all those kind of things that we need to do in the modern world to preserve the integrity of brands. So the other thing is, because we can embed these at the molecular level, they're tamper-proof. So when you put something into an actual material or medium, it's very different than when you place a sticker on something or stick an electrical device on something. So let's talk about how the platform works. So this is obviously a simplified view of how we do things. So the product itself can be made of many different materials or mediums, as we call them. So whether that medium is the canvas in a tennis shoe, a particular thread that's dyed inside of a patch or emblem, a metal tag that goes on top of a product, or anything that's included inside a product, a leather in a purse. All of those things in the product can actually be embedded with the QDX signature. By using the wavelengths that can be created using quantum dots, we go through a process that creates a batch of dots that can then be tuned to a particular signature, which is then embedded in the manufacturing process for an individual product. There are a lot of different ways to do this. Obviously, it depends on whether we're making paper, leather, metals, all those kinds of things, or whether products are combined at a later date through using different kinds of processes, different polymers, adhesives, all those kind of things. Then using our QDX Authenticator, which can be either an industrial version that can be everything from mounted physically in a factory or in a distribution location, or placed upon something like a drone so that it can actually move through the warehouse and validate things, or running off a mobile device like your smartphone to be able to do those things. Those then tie directly back to our customer systems so that your standard supply chain systems, whether that's SAP, Oracle, any of those things that you're using today, we can match those product batch IDs that you normally track products by with the same quantum signature that we have in our QDX ledger. So the whole purpose of this is to disrupt the current supply chain as little as possible, make sure that we use an immutable ledger so that we can connect to all of the different audit systems, that we can also share that information with third parties, particularly in anti-counterfeiting, where we're trying to track bad behavior and bad actors in various different ways, and always make it very easy to authenticate the signatures on the products, even in places where there isn't sophisticated technology. So many of the things that we would embed our signatures in are not things that you would typically today think would be easy to make anti-counterfeiting work with. So in the case of, say, brake pads or drums or things like that, these would be very challenging, you know, to put a UPC code on, or to put a RFID tag on, or those kinds of things. Therefore, they're very prone to counterfeiting. They're easy to have a way with them because they don't have exposed serial numbers or things like that. Same thing occurs with some other use cases that John Hartigan's going to talk about in a little bit. In our case, you can see our quantum authenticator over on the little mobile device that are on the side. And I'm just going to walk through a very quick way of how we do those things. Not only do I identify products, but in order to be able to work in the supply chain, particularly as products are transferred from one group to another, so from manufacturing to distribution, distribution to retail, and then retail to the customer, not only do we need to be able to authenticate the products, but we need to be able to authenticate the participants in that process. So we use a concept of a signature for our products that we're going to authenticate, and we use something called a sigil to designate a participant. It works very much the same way as the signature for the products, except in this case, when it's a signature assigned to a person, it can actually be embedded, for example, in our QDX inks or in different kinds of things that a person can use to prove who they are. So as you'll see here, here's an example of Bob using a sigil to authenticate himself to enter into a process with a product. In this case, we're using a particular ink that is embedded with Bob's signature. And when he presents the device with that ink on it, we can actually authenticate that it's actually Bob. And once Bob's authenticated, he can then go in and authenticate other products and anything else that's involved in his supply chain. So the other key part of the advantage of the platform and the way we've designed it is that it's designed to be totally integrated with existing scanning and supply chain systems. It's also designed to be integrated with other tools on the blockchain, so that basically any other blockchain that exists and wants to be able to share information or tokenize things within their supply chain or track and trace systems that they're doing, we can use the digital asset markup language, DAML, to be able to interact with them and manage any assets that are put on their chain. And because we're using our molecular integrated dots, we can actually put those in ink, which can also match up with the UPC codes, QR codes, and other kinds of labeling that already exists in the existing systems. So with that, I'd like to turn it over to our CRO, John Hartigan, to talk more in detail about how we do this for business.
Hi, everybody. It's a pleasure to be able to talk with you today. As I think you're starting to kind of get a feel for, this is an exciting technology. We have got a tiger by the tail here, and what my goal today is to show you what this means for consumers as well as brands and industry, and to perhaps open your eyes to the many possibilities of what this technology will allow. This Christmas season, billions of people will be shopping online, and hundreds of millions of people, unfortunately, will be receiving counterfeit items. Many of the times they won't even know until much later that they have received a counterfeit item. The proliferation of online shopping has created a whole new opportunity for counterfeiters and fraud to enter our supply chain systems to unknowing customers. Now, in many cases, like for example, my son and Pokemon cards, that is not exactly a real problem ultimately, but in other cases, such as pharmaceuticals, such as brake pads, such as e-cigarettes, this can be a serious health problem, serious risks to the consumers, as well as serious risks to the industry that is attempting to keep them safe. We had a slide on there showing shoes, and one of the reasons I wanted to put that on there was because of the fact that of all counterfeited items, shoes are by far the greatest counterfeited item. Over 22% approximately of all counterfeit items are shoes. So we have had an overwhelming response from multiple sectors, including many sectors that we were not, or at least I was not expecting to be able to leverage this technology. And obviously luxury brands and fashion are some of the first ones that come to mind, including luxury watches, luxury handbags, and etc. Apparel, for example. And yes, we can address all of those issues via including the quantum dots and the QDX platform into items such as leather, into fabrics, into threads, into buttons, and other intrinsic items or parts of the apparel and the fashion, and even into parts of watches, for example. One of the most exciting opportunities that we have is the introduction of quantum dot ink. So as you can imagine, ink is used in everything from the printing of UPC codes to the printing of currencies, security documents, government documents, passports, et cetera, et cetera. And they are constantly trying to find ways to improve their security, and they use holograms, they use security threads, they use all different types of means to advance security on the documents. However, the counterfeiters are always right at their heels and are, excellent at being able to replicate those items. So one of the first items that we have brought to bear is a quantum dot ink that cannot be replicated by counterfeiters in any way. And the beauty of this ink is that it can be included in current supply chain equipment for the printing of packaging and actually the printing on certain items, et cetera, including currencies, documents, passports. And this ink will look like normal ink. And so, for example, if you could think of being at the store or in a distribution center and you were scanning UPC codes or QR codes that are pretty much printed on everything now, those QR codes and those UPC codes are very easily copyable. And so if you included Quantum.Inc. to print those UPC codes or those QR codes, and you had one of the scanners that would allow you to scan that item, you would know that that packaging, that item had come from the correct OEM source or the correct vendor that would be the only one that would be able to have your ink. Because the supply chain problem is not one at the OEM level typically. However, the supply chains are larger and more complex than they have ever been. There are vendors that are global, and it is very common for counterfeit items or fraud items to come in at different points in the supply chain. And with this technology, you are able to, from inception, from the birth of the product, all the way through to the consumer and beyond the consumer, including warranty type identification and authentication issues. So the complete life cycle of the product, these quantum dots are incorporated and can be scanned, and then they can be referenced on an immutable blockchain. So the brand has the absolute assurance that those items are either their items or they're not their items, and they can see all along the life of the product. This is incredibly important. And you'll see an example here of the printed QR codes and the capability of doing that. One of the industries that we have had some of the most interest from is the oil and gas industry, which when I heard this opportunity, it wasn't exactly the first thing that came to mind. My thoughts were pharmaceutical, my thoughts were luxury watches, and you know, the items that we all kind of think about when we go down into that one street in the city where you know they have knockoffs. Well, oil and gas has a big problem with counterfeit oil, motor oil. Specifically in Asia and other countries, this is a significant cost to the brands. And we were actually approached by a Fortune 100 oil company that said, hey, can you put this in motor oil? And I said, yes, I think we can. And so we did tests and we proved that we can, in fact, create anti-counterfeit motor oil, which they found extremely exciting. We can also do a number of other things in the oil and gas space. We can be included in things like fracking sand to identify the quality of the fracking sand, where it came from, where it got put in, and then also too the appropriate disposal of fracking sand. We can also include quantum dots in crude oil. So when the crude is pulled out of the ground, let's say in the Middle East, we can include tracers in the crude oil that can be then identified at the processing plants or at the refineries, and to make sure that this oil didn't make some kind of unscheduled stop somewhere along the chain. Very important, and up until this point, very difficult for big oil to do. Another use case that was brought up was the idea of being able to use the quantum dots as maintenance tracers in all of the refining facilities and the pipes and the pipelines, et cetera. Because as you can imagine, maintenance on these facilities and infrastructure is extremely expensive. And this would be a way for them to identify where the problems lie, where they need to create better maintenance programs, et cetera. And the list goes on and on, including tanker tracking and trace, and many others. I mentioned apparel earlier. We have had numerous inquiries from different luxury brands, including apparel. And like I said, 22% of all counterfeit items that they are aware of are in the footwear department. Again, that was shocking to me. And that's actually twice as many by percentage as anything else. And so we can do things like put the quantum dots in the soles of shoes or in the laces of shoes or in, like, as Jay mentioned, the canvas of the shoes. We could do a combination thereof. If, you know, Kanye West has these Yeezy, I think they're called Yeezy shoes. And for my generation, that doesn't mean anything, but for the current generation, those are the top selling shoes. They go for $600 or $700 a pair, kind of like the Michael Jordans did back in the 80s when I was a kid. And so what we're looking at here is very broad application. But what I love about this is the fact that though it's a broad application, our ability to bring our products to market are the same. It's the same technology and it's the same product offering that we will be offering all of these sectors. And that allows us a unique ability for scale and scalability in this particular space, because it's quantum dots that are uncopyable, that are associated with blockchain, and they do the same thing for every product and service in the supply chain. So it's a very elegant solution to what the industry so needs right now. And as I'm saying, we're going into the Christmas season, and I'll tell you, I hate to admit it, but most likely I'm probably going to get some counterfeit product in my Amazon boxes here pretty soon. And now I hope that's not the case. And I hope that you out there don't have that same problem. The hope we have is that by incorporating quantum dots into the supply chain and into products, that we will be able to restore the trust in brands, restore the trust in online shopping, and restore the safety in the products that we use every single day. And at this point, I wanted to just mention a couple of other industries that we are in talks with, and we are very hopeful that we will be announcing our very first big partner before the end of this year. Some of the other and perhaps less obvious industries that we are working with include, as Jay mentioned, supply chain, but also industrial recycling, for example, recycled plastics. Also, the track and trace and collection and disposal of these items is a huge global problem. We are also in discussions with a global seed project that has to do with the track and trace of forestry seeds and other agricultural products. We are also involved with very large tobacco and e-cigarette industry projects in order to secure the tobacco supply chain and also the e-cigarette cartridge supply chain. As you know, that has been in the news as of late, and our hope is to make that safer. So all of that said, very exciting. We are excited to bring this to market, and we see extremely huge opportunities. Thank you.
Okay, thank you to John and also to Jay and to Steve. So we've actually received some very good questions right now. So going to address these. Thank you for sending these questions in, by the way, and we're happy to take a few more if you want to send those. Just putting John's slide up so you can contact him if you wish to. So here's a question about the blockchain distributed ledger technology that we use. And the question is, all the current major DLT offerings suffer because of their performance related to scalability and that's really driven by the consensus mechanism that they use. How do we plan to address that at Quantum Materials?
Hi, everybody. It's Jay Williams. So a couple of things. Definitely, there are many, many issues with the adoption of blockchain and DLT technology across there. There have been many POCs in many different industries over the past 3 years that have been trying to address these things. We use the Hyperledger Sawtooth platform for our DLT to handle all of the different kinds of things we do. We have our own form of consensus that we use, which again, happy to talk about these in detail. In fact, I'm sure we'll have a technology webinar similar to this sometime soon. You can probably also see some of our latest press releases. We're working with several different companies. KubeCon's going on today, so I know people are out talking about it at a conference out in San Diego as well. So from a scalability and a transport standpoint, we actually use 2 separate blockchains to do parts of what we do. But definitely, you know, the consensus mechanism and the way we deliver things is very important to us. So good question.
Okay, here's another one which actually just came in, bit of a different question. What is the lifespan of quantum dots? Can they degrade over time? What is that effect on the ability to track items?
So this is Steve Squires. We can make quantum dots out of a broad range of materials. We can also preserve them in different mediums. So what we've done is develop a really broad range of different quantum dots for different applications. And we're continuing to build on that as to the mediums that we supply them in to make them not just compatible with the surface or the product that they're going in, but also to be able to do so in a manner that allows them to have very long life. You know, so one of the things I think that we can fall back on to historically is that, you know, we've made quantum dots in solar cells, and in solar applications, they have to be in the sun and they have to have a 20-year life. So, you know, we've developed the skills to be able to make quantum dots very robust. And we are just, we've pushed that envelope farther to where we can make them robust and also be very efficient emitters.
Okay. Another question here related to the sigil. Are there protections if someone loses their sigil or if it's stolen?
So let me combine this with a couple of other questions that have come in around security and how does this work and with the blockchain and different kinds of things like that. So first of all, being a blockchain DLT based technology, we use various cryptographic means to create secure wallets for everybody that uses our applications. And so it works very much like the maintaining of a cryptocurrency kind of wallet so that you're protecting your chain. It works very much like a 2-factor authentication system in that there are public and private keys. And so there's key management involved in our complete process. So for example, in the case of a sigil, if it's lost or stolen, we don't just use the quantum signature as a method of authenticating the user. We use other methods as well. To create what we call 3-factor authentication. But again, when we have a more technical webinar and we do some of those things, and if you're interested in finding out about that, we'd be happy to have John Hartigan contact you and take you through our process. Many of the things that we're working on today, of course, are under NDA. So in this webinar, we're trying to do it in a very high level. Again, if you want more detailed information, we're happy to share and would love to do that. I'd like to answer one more question that's come in quite a bit, is the question of, how do you actually scan these signatures? How does that actually work? Well, these signatures are generated in visible wavelength. And so using technology that exists today in our mobile phones, as well as third-party systems that use inexpensive forms of spectrographic analysis, we have our authenticators use that scanning technology combined with technology on the blockchain and technology in AI to be able to actually scan the individual products. One more question that's related to that also was whether there were drawbacks or undesired side effects and things of integrating the products together with others. Well, obviously with anything, there can be side effects when you decide to do things, but because we're using basically inert materials to build these artificial molecules. We combine them with other polymers and things like that that we test for. We make sure that none of those exist, when we go through the process. And obviously there are many certification programs for the different products our manufacturers are using. So as we embed these or associate these with those products, they'll go through their standard testing processes, just like the regular, any other product consumer product or any other product that you would buy.
Okay, so one more question that we see is there a difference between the quantum materials offering and other track and trace systems that use things like QR codes, RFID tags? What's the unique advantage of our approach?
So from a technical aspect, many people have been trying to create technologies over the years to associate the physical and the digital. So IBM has products out there. There are multitudes of products that are doing different kinds of things with nanotechnology to enable it to be used for identification. So there are physical forms of dust that people have created that you sprinkle on things to be able to do it. There are different kinds of products that embed these in different solutions and properties so you can paste them on things and do things. The difference between many of those approaches and what we're doing is twofold. First, most of those depend on the actual application of the dots in a specific way to something so that they can create a pattern out of the dots onto something. So then that pattern is then assigned a particular significance, and then it's read by a particular device through the wavelengths. In our case, we've developed a particular way to create a unique signature that can be associated at the creation of the dots, right? So it's very different in a process of how we do it, because our serialization process works with our technology that we have on our quantum dot creation side, which is very different than the batch process and the way most people make dots today. So because of our technological advantages we have in the way we make dots, we've created a way that we create our signatures that works with that in real time, so that we can be very unique in how we generate and record those. Also, with the inclusion of the blockchain at the creation level of the dots, as well as the application level of the supply chain, we can now tie those two sets of technologies together so that we use our signatures in a very unique way.
Okay, question for Steve. You mentioned that over 1 billion dots typically go into a single droplet. So the question I would like to know, generally, how many dots would go into a single product? Now, it's a wide range, but could you speak to that?
Yeah, first I'd just like to clarify, there's actually 1 trillion dots in a droplet. So there's a lot. It takes very few dots to be able to get an optical signature. Again, it would depend on what the application is, but the amount of material that's used is not very significant in order to be able to get a good optical signature. And then I just want to stress the application of the dots to products is very simple. I mean, we've designed the entire product to be able to really integrate easily with companies' existing protocols and how they mark their products. So the integration is simple. The cost of the dots is really not very significant. We've tried to price the entire platform to where it's easily integrated and affordable when compared to what the downside risks are. For most product manufacturers, just the product liability side far exceeds what the cost of implementing this technology is.
Okay, one more interesting one. Are quantum dots safe? How do they affect the products that they're embedded in and the people that use them?
So one nice thing about quantum dots is the performance that we are extracting from them is based on quantum confinement. So the elements that we make them out of is really not the driving factor. Certainly there are some elements that are more, perform better in crystallization and maybe take less energy to get higher emission from them. But fortunately for these applications, we don't need very high emission. And so it really opens up a broad range of materials for us to use. So we've developed biocompatible materials for medical applications. we certainly can draw on that experience to be able to use those types of dots for applications where there may be some sensitivity. The fact, are there any risks associated with just the dots themselves because of their size? We're embedding them in almost every case in some type of a carrier or polymer. So they're very well secured. They're molecularly bonded, so they're going in virtually into the porosity of whatever it is that we're applying them to, which then adds another layer of adherence to that. So they're very unlikely to become uncoupled from what we're attaching them to. And there's been quite a few studies, and I think there'll be more studies ongoing. But there are a lot of nanomaterials found in nature. I mean, currently, carbon black is a nanomaterial. It's been around forever. So, I think that from the studies I've read, there's very few risk to the materials that we're using, and we're very cognizant to making sure we use biocompatible materials when the application requires it.
Okay, one more. Is the signature a random process at the point of creation?
Well, I'm going to take this one and answer it in a little bit broader way because we've got quite a few questions around how does the signature work? How do we do those kind of things? First, it's not random. We actually have a methodology for creating a signature. And if you want to think about it similar to the way an IP address works today, when you think about how you address a particular node or object on the internet, it's a very similar process to how we use wavelengths to be able to create a specific signature that we can then use to embed in things. One of the other questions is, how much data can be stored in a quantum dot? The answer is not really so much how much data can be stored in a quantum dot, but how are the dots arranged so that they can create an intelligent signature? Each of these dots, as we talk about them, as Steve mentioned, there are trillions in a particular, droplet. Well, in this case, we use an aligned set of dots that are different frequencies to form a signature or code that we can then embed in things. There was also a question about, heat, what can we embed these in? How can they do it? Do they survive, et cetera? There are many different kinds of dots. We have many recipes for how we make different dots to survive in different kinds of environments, whether those are dots that are going into a solar cell kind of environment, dots that would go into a furnace level environment where we're making very high heat, high temperature kinds of things, or dots that need to exist at the bottom of the ocean to identify things under high pressure or temperature. So those are all different kinds of places that dots can operate. One of the questions that's associated with that was around how do we read all of those dots? Well, again, depending on the environment, whether we're reading them at a manufacturer level, there's obviously a huge difference between reading a tax stab, on a carton of cigarettes and reading the Gucci logo, something else in a particular place or time. So all those different things, can impact, the way we read and the way we use our authenticators and the way we put things together.
Right. So I think we may have time for possibly one more question, and it's a good one for the holiday season. How would you use this for a product like bourbon, maybe a very high-end bourbon, which I hope you'll be buying me for the holidays? How would you actually incorporate it? Maybe John could take this one.
It's an excellent question, one that I have pondered greatly because I enjoy bourbon and actually other spirits. So there is a way to incorporate dots into different, shall I say, liquids. And now, in this particular case, Steve was mentioning that we can manufacture dots out of inert substances such as carbon, etc. And so there's already been a discussion about potentially creating quantum vodka. So by the way, I'm trademarking that right now, right here, quantum vodka. Okay, so yes, and it's in parts per billion that the dots would show up, and then when you emit, they would emit light. So if you introduced an energy source, your beverage would illuminate.
Great. So I think with that question, we're out of time today. As I noted earlier, please contact John Hardigan. His information is on the slide showing right now. If you have a specific business follow-up, For others that submitted questions that we didn't get round to, we have noted them. We'll be able to address them as appropriate one-on-one via email over the next day or so. But thanks everyone for your time and your interest. Have a great day, and I hope all of your dreams come true with non-counterfeit products this holiday season.